Hello everyone. This video will show how to maximize the area using the graphical method. So let's go over this problem right here. A farmer has 500 feet of fencing to enclose a rectangular lot with a wall on one side. What are the dimensions of the lot that makes the area as large as possible? So the first step that we need to do is to sketch and label the given problem. So I'm just going to go ahead and sketch that up here. In this problem right here, we are given that the farmer has a 500 feet of fencing materials. So this 500 feet that we have right here would cover the perimeter of this rectangular lot. So the perimeter for this rectangular lot that we have right here would be, it's the sum of all the measures on the side. So that would be W plus L. Because he doesn't need a fencing material because we already have a wall here. So we plug the values in. So our perimeter is 500. So this becomes 500 equals combining like terms. So that's 2W plus L. So we are going to isolate the L by itself here. So we go ahead and subtract 2W from both sides. So this is the formula for the length in terms of width. Now we are going to determine the quantity that we need to maximize in this problem. So in this case right here, we see the word maximize. We're using the word maximize here because we see the word large. And the quantity that we need to maximize based on this problem is the area. So we wanted to make the area as large as possible. So I'm just going to go ahead and write that up here. The formula for the area of this rectangular lot is length times width. Since we know that the formula of the length in terms of its width is this, I'm going to go ahead and plug it into the length right here. So this equation would come out. So I took this whole thing, plug it into the length, and we have multiplied it with the width. So we're going to distribute the width to each of the terms inside the parentheses. So our equation would come out. Now we're going to change the variables to x and y, and we're going to use decimals to determine the maximum point of this equation. So in this case right here, we can go ahead and let y be equal to the area and the width equal to the x. So this equation that we have right here would come out. Now we're going to use decimals to sketch this graph, and we determine the maximum point of the graph. Looking at the graph on the side, the maximum point is 125, 31,250. So I'm just going to go ahead and write that up here. This is our x and this is our y. Since we say that our x is the width, this 125 represents the width of the lot, and this y represents the area of the lot. To find the length of the lot, we are going to use this equation for length in terms of width. But this time around, we're going to plug in the value of width, which is 125. So I'm just going to go ahead and show that work up here. So we can see that our length is 250. And the parameter, I just wrote that up here. The parameter was actually given to us, which is 500 feet. So that is how we maximize the area using graphical method.